Okay, so for the next question, it is saying that how do you find the domain and range of a function in interval notation? So domain and range of a function in interval notation. Yeah. So I will like it is first thing it is a theoretical question. So I'm not going to write this theory again because it will take my whole time. So I'll just read the important points like the domain of a function is all possible values of x where the function is still defined. So this one is important. All values of x where function is defined but yeah, remember one thing that the function is of x only in this case. Like if we have a function of y, then obviously the we'll be writing y here instead of x. And we find the range um, for a polynomial function. Its domain and range would be the set of all real numbers. So it is going to be from minus infinity to plus infinity. But we check with the function that at what points there is a breakage or there the values like for what values of x the function is not defined, then we exclude those values from the given range. So this is the range of real numbers. So here we have some cases. So I'll just explain the cases. They are basically, I guess, 1, 2, 3, 4, 5, 6. Yeah. So there are 6 cases, and obviously we can go for the number line representation also. So I'll define with first case. Now in the first case, the thing is that the interval is a finite interval. So it is a finite interval and it is a closed interval. So this closed and open intervals means a lot. So it says that in notation. So for closed interval we write a square bracket, and for open one we'll just write the normal bracket. So for closed one, a comma b. So it says that my function or the range of the function is from a to b, where values of a and b is also included in the function, and or also included in the range. So let's say this is the number line. And just again make this number line. So let's say this is the number line. Then let's say this is the value a, this one is b, this will go to negative infinity, this will go to positive infinity, and I will use a different color, blue color. So my values of the function are defined in this region, in the blue region, and also a and b also satisfies the function or the function is also defined at values of a and b. So therefore, this is the first case where we have a finite interval and closed one. The second one is finite open interval, which is open. So for the case of so for the case of open interval, we write normal brackets. So this is the notation, and again, according to number line, I'll tell you. Let's say this is the value a, this is the b, then my function will be defined. This kind of circle means that the values at this particular point is not included, and for rest of the values, and so for all the values which lies between a and b, not including a and b, okay, for all those values, my function will be defined, or my or all these values are going to be the range, or all these values will lie in the domain of my function. So this means that we are not including a and b. In the first one we included a and b, so I can just make a color dot here, but here it will be a kind of circle. For the third case, it is half open, half close, and that too finite. So that means here also we can have two cases. So half open, half closed means first of all, this is finite because it is from a to b. Second, you can see that here a is written with a normal bracket and b is written with a square bracket. That means the value from a to b will be in the range or will be in the domain. The value of b is also going to be in the domain, but not the value of a. The same applies here. The value of b is not included, but a is included, and all the values between a and b is included. So if I draw a, b, again a, b, then with my blue color a is not included, I'll draw just a circle here, and for b I'll just make it a little bit darker, and this is going to be my number line, and for here a is included, b is a circle. So this will be such kind of line. Again, I just, yeah. So this is the half open and half closed interval, where plus finite interval obviously. Now we have three cases with finite. We'll be having three cases with infinite. Okay, so these cases are also going to be the same. Sorry, this one is fourth one, and that was it. That is infinite and closed. And closed. So this is infinite and closed is easy. Basically, okay. So for this, again we'll be having two cases. And let's say we have here we have b, and let's say here we have a, minus infinity, positive, positive, negative. So for this one, infinite and closed, I don't think that infinite and closed. Okay, yeah, I was right. So basically, we never write a square bracket with infinity, because the thing is that infinity is a not defined number you cannot include the value, we cannot just write infinity there. So therefore we always write infinity with a curly bracket, and here b is, so, and it is again a closed interval. Here we'll be writing a square is needed, and for that is positive infinity in curly bracket. So here b will be included and it will go, so this line will go till minus infinity, and here also a is included and it will go to plus infinity. It will keep going on. So again I'm repeating that in the case of infinity, we do not include the infinity, or we do not write infinite in the square bracket. That was fifth. This is going to be fifth one. So for fifth one we have infinite and open loop. Okay, this is infinite and open loop. Again we'll have two number lines here. Again first one will go with b, second one will go with a. Now in the previous case, I already told you that we'll not include in, or will not um, write a square bracket with infinity. So in the case of closed one, we just operated the closed or square bracket at finite terms. Here we'll again operate the open or the curly bracket with finite terms also. Like obviously it is included with infinity, but yep, we'll be writing it with finite terms also. So here it will be minus infinity till b, but b is not included. Here it is a from infinity, but a is not included. So I'll draw a circle here. That means a and b are not included, and this is from minus infinity. This one is to till plus infinity. And last is infinite and open. So that is the case for real numbers. Sixth one is and open. Well, in the last case or in the previous two cases, they should have written like infinite and closed finite, and infinite and um, open finite, because infinite and open, we have two infinite and open, which will, like, it can clash with each other. But so infinite and open, again this is the number line, minus infinity to plus infinity. I'm not going to draw with blue here because, yep. So infinite and open will be from minus infinity to plus infinity, and that is also the range of all real numbers. Basically all real numbers are from minus infinity to plus infinity. And again I'm not going to draw blue line because it will just overlap with this red color. So I guess that was all for this question. This was a lengthy question and was question number 3. I just first write correct solution here. Nice work. This will be